Hello, everybody. Good morning. Thank you for being here. My name is Gabriel. I'm very excited to introduce you to my capstone project. A little bit of backstory. So previous to this, I was working as a server in the restaurant industry, working roughly about 60 hours a week, just kind of, grinding. No coding experience. I just kind of came into this program with a lot of insight on not this technology, but just other technology, but very eager to learn all of that we've been learning. So it's been really a great experience. I feel very confident that when I'm leaving this program, I've already gained a tremendous amount of knowledge about IoT devices, coding with C++, 3D printing, laser cutting, soldering, wiring breadboards. So it's been a really good experience. And this is a little bit of the parts that I was using. I didn't include the two clouds that I also used, which was the Bluefruit app and also the Adafruit. And I definitely utilized a lot of my skills for this project. So pretty much everything that I listed before, I mean, it was a lot to learn, but it was, a good way to get to where I'm at. And I couldn't have done it without the help of the teachers. So I received my inspiration pretty much just one day with my cat. I was at home and I was just kind of thinking, imagine what it would be like to be an indoor cat. It's got to get boring at times. So I thought, maybe I can make something that would kind of keep her entertained while I'm not home. I designed the ball to be a toy for any pet, not just cats. But just like a remote control car, it has a controller to control it, except in this case, the cat is the controller. Around the cat's collar is a BLE beacon that senses the distance from the cat to the toy. And when the cat gets within a few feet of the toy, it turns on and starts to move. It also lights up with using a strip of neopixels attached to the inside. Inside of the ball is a DC motor with a lever attached to it that kind of propels the ball into motion. I 3D printed the lever and then I laser cut the piece that kind of holds pretty much everything together inside of the ball. Since everything was mounted on either side of the panel, the breadboard and everything that's plugged into it gets to kind of go for a ride. So it gets a little bumpy at times. But while making the lever and the 3D printer, I did run into a challenge with the printer. It didn't necessarily print right. And so I had to kind of utilize tape, which always helps, and got that to work correctly. So a little bit more about the BLE iBeacon. BLE just stands for Bluetooth Low Energy. And so this is one of the topics that we hadn't researched in class. So I had to kind of do my own research on that and see how it worked. So using a standard Bluetooth device or Bluetooth wouldn't have necessarily worked in my project or wouldn't have worked very well, mainly because the battery life of it. The BLE beacon can offer a very extended battery life. So it can actually last anywhere from about 10 months to 4 years, just depending on the user. So you can set the interval between it sending out its signal, and that basically means that the less frequent that the signal is being transmitted, the longer the battery life will be. So you can get a pretty substantial amount of time out of one of those. And one of the other issues that I kind of ran into early on in the project was just getting enough power to the motor to get it to run. So I hooked up a relay that converted the incoming voltage, which was 3.7 volts to 5 volts, which is what the motor actually needs in order to work. And by converting a wire, by connecting a wire from the relay to the emitter pin on a NPN transistor, and then connected another wire from one of the pins on the argon to the base of the transistor, which is the power part of the transistor, it pretty much was a success. I also had to use 2 resistors in this case, which kind of helped to amplify the power to the relay, and then from the relay to the motor. So it was started off at 3.7 volts, and then it amplified it to 5 volts so that I could actually get the ball to run. Towards the end of the capstone, I faced a few other challenges, and one of the biggest ones was plugging in the argon. So in order to plug in the argon, I had to take everything out of the ball, and then I would have to put it all back in and get it to kind of stay in one place. And then also if I had to upload anything to my code, that was an issue I ran into because I also had to take everything out again, which was a pain. But didn't really damage a whole lot in there in the process, which was good. I did have to replace the motor towards the end of it because that did get damaged, so that was a little tricky. But another challenge that I was faced with was the beacon didn't seem to be putting out a consistent read, which is it reads the RSSI, which is the received signal strength indicator. And in order to kind of overcome that, I decided to publish my RSSI feed, or the distance pretty much between the ball and the toy. I published it to Adafruit so I could get a live kind of display of, how it was displaying, or how far the distance was between the ball, or between the cat and the ball. And that worked pretty well. I also created a manual on and off switch in the Bluefruit app. So if the ball, for whatever reason, I needed to turn it off, or if it was, just not working right, I could do that. So throughout the class, I faced lots of challenges, but thanks to Brian, EJ, Reed, and then also my fellow classmates, I was definitely able to overcome all of it. And I feel like I've learned very useful skills that I can implement into the real world, and I'm looking forward to doing that. So this program has been a really huge opportunity for me, and I just would like to thank everyone who has helped me get to this point. So thank you all for being here, and I hope you enjoy the video. Likes to run into a lot of stuff. My cat wouldn't cooperate, so we had to improvise. But she did like it a little bit, so. Well, I sure hope everybody enjoyed the show. Thank you all for participating in our presentations, and thank you all for watching.